Hello, welcome back again into my tutorial channel. So this channel is dedicated for all engineers to get better knowledge and skill while using the CAE and CAM software. So in this video, I will explain how to create a simulation for the stamping process using FTI FormingSuite. This is example 2 for the metal stamping simulation. And in here, the difference between example 1 and example 2, in here I will create the 3D addendum and then go to nesting and finally into costing. So the difference is in 3D addendum, and also I will show you after we create 3D addendum, we can create what is called a Springback after trimming. So this is the Springback calculation after we trim the finished product from this 3D addendum. Now this 3D addendum is automatically can be created using FTI FormingSuite, and then after that I will do some examination for the thickness and the safety zone using FLD, and there's a split in here, and that's a good thing. I can show you the type of failure in stepping simulation using FLD. For example, if I zoom in here, you can see there is some kind of dot in here, so this is going to be split. And after that I will continue to the nesting and then go into the process and see the costing calculation. So in this tutorial, I will show how to create stamping simulation process using FTI FormingSuite. The part I use is still the same. In here, the round wheel part is from the example geometry, but there is slightly change on the step between the previous one, the example one, with this. You can see in here, I create what is called 3D addendum. So this is the 3D addendum. It automatically created by FTI FormingSuite. And in here, we can extract the tooling. So after we create the addendum, we can extract punch, blank holder, and die. Okay, so let's close the project. We start new project. As usual, create a new project by clicking this one. And then before I start, I usually go to project setting first, go to the unit, change the force units from Newton become ton force, remove the decimal and then click OK. And also in here I will change the currency. By default is United States dollar. I'm gonna use 2 decimal only. Then after this we go into geometry. Now we're still using the same geometry. It's located inside this geo folder. The geo folder came with the installation. So you can go into Windows, Program Files, FTI, Geo. We open the same part like this example one. It's called zone wheel part, the IGS part in here. Click open. So this is the same part that we use in the example one. Okay. Then in here we can define material. We're gonna use the same material, same thickness also 1 millimeters. And for the properties, we can go into the cost, input the same cost. Okay, you must input this one in order to get the price calculation or the cost estimation at the end of this project. Okay, and click OK. For the thickness and direction, still same in the middle. And then next in here, before I go to create 3D addendum, I will create this one. Create direction factor first. Okay, there's an option in here. I'm gonna use the normal to picket point, like same like the example one. I click the surface and then I flip to the top in here. Now in here, I will give some simple clue, maybe some kind of tip in here. When I create the binder, okay, this is create binder. before creating the addendum. So you see in here, the direction factor is going to up. Okay. So when I click the binder, so it will create on the bottom. Now if I flip like this one, when I click the binder, it will create on the top. Okay. Now let me go back, flip this. Okay, and then I click OK. Now here I ready to create the binder. Okay, like this, create. Okay. Now before I go and then click the preview, let me align first on the view in here. There's a three option in here: punch direction, and punch direction side A, punch direction side B. So the best view is the punch direction side A. So when I create the binder, we have two options in here: flat and silhouette. Okay, let me show the flat one like this. Okay, so it will create something like this. Okay, let's go back again into the punch direction side A. And also there's an option called a silhouette. Let's click the preview. So this is the silhouette. You can freely adjust all this arrow like this. Okay, so you can adjust this arrow and it creates something like this. Okay, now as you can see, the location of the binder itself is highly dependent on the view in here. For example, if I choose isometric in here, when I click view and I using the silhouette and I click preview again like this, or it will create something like this, right? So this is wrong. Okay, this is wrong. So it means you must adjust first as good as possible the view. Okay, let's clear it again and then click the silhouette again, preview like this. So it will create the good preview, create a great the binder in here. This is the correct one. After this, I can click OK. And remember, you must give a gap in here. So I will put -10 in here. And then I can click OK. Now we got the binder. So it's like a surface. And it will be used as a base surface for 3D addendum. So next, we're going to go into 3D addendum. Click this. Select geometry. Since we only have one, geometry set only one, and also there's a fraction already defined before, then we can go click OK. Next is create the path extension curve. This is the path extension curve. So in here, we have a curve offset. This is the offset. If I increase the offset, become 10 millimeters. Now it becomes 10 millimeters. And also in here, we have a fillet radius. So what is fillet radius in path extension curve? Maybe I will, okay, I will write it first. Now, the fillet radius is the radius surface connecting between the finished product into the binder surface. So the radius in here, okay. And there are two options in here for the shape, the smoothness and the convexity. Right here, I see there's a sharp edges, so I will make it smoother by slightly change using the slider in here. It will become smooth. So you must examine each of the curve. Is there any sharp edges or not? Okay. After this, if you feels okay with the curve, you can finish it and then click next. Create die radius tangent. So it's like projecting all these curves into the binder surface with draft angle 6 degree. So this is the draft angle. So this is the draft angle. Okay, this one. Okay, so the connecting surface will be have a draft angle about 6 degree. And the fillet radius in here is radius between the surface and surface connecting here and the binder surface. Also, you need to check is there any sharp edges? If you have found, you can use the smoothness slider. Now you can change in here so it become less sharp. Okay, click OK. This one. Next, we can create die face. So there are 4 options. If you don't know what is the difference, it's easy. You can go to help. It will go directly. This one. So there are 4 options. Adjust the punch radius. So the curve will edit result in local variation of the punch radius. The radius, so the radius will be adjust. The other will keep fixed. Adjust radius proportionally. Of course, you can use this one, okay, and then it will proportionally change the radius. And also you can adjust the draft angle. So it means the draft angle is not always in 6 degrees. Okay, it will change variation in draft angle while maintain other in the fixed value. So in here I usually using this one, adjust radius proportionally in order to maintain the draft angle still the same at every location. I can click OK. Okay, this is the result of FTI FormingSuite automatically create the extended surface to connecting between the finished part and the binder surface. This is the result. It's good. Okay, next we can create the trim lines. So this is the trim lines that will trim the part from the sheet metal. This is the trim 2D. We generate like this. So you can see all the color is green. It's green, so it means we can directly trim the final product from the sheet metal. If the color is red, it means you must have a CAM mechanism to make the trim. Okay. Next, create bonded trim. So it will cut the binder surface. Okay, let me check, is there any sharp edges? If not, I can go just directly click OK, and then create the first form. Click OK. Now this is the first form. This is the 3D addendum, like this. Okay, and then the function for this is also for the tooling. So when I click this one, create tooling, it will automatically create the punch, blank holder, and also the die. And you can export this one individually into the project, so it will save as IGES file. Okay, blank holder also you can export, and also the die you can export. Okay, okay, now let's go into the process setup. In the tool mesh setting, FTI FormingSuite give the recommendation maximum element size about 23 millimeters. I will change this become 10 millimeters. Now it's already mesh. Let's see the mesh, the element distribution is good. It captured the details in here and also the details in here. Okay, let's go back again like this one. Okay, now we are ready to define the punch direction. We're still using this one, the direction vector 1 that already created at the beginning. So let me check about the undercut. Is there any undercut in here? Yep, there's a slight undercut in here. It's outside the finished product, but let's see what will happen. Okay, and also draft angle and trim condition. Okay, this is the trim condition. Okay, and then define the forming process. If you don't know which one to choose, the software will give you the clue this is draw. But if you don't know, you can just click auto, and then you can solve the forming. Now, we get the flat blank, the green color, and the final form, the gray color. Let's go into the final form first. You can examine here the safety zone. The safety zone in here. Okay, you can also check the forming zone. Okay, now for the explanation for this, you can go to help. It will directly pointing into the topics in here. For example, in here topic is forming zone. The help is straightly go into forming zone also. So this is what we call the type panel in here. Type panel. This is the illustration. Plane strain, semi-tight panel, loose material, wrinkle, and strong wrinkle analysis. So this is a good illustration about what is the this one tight panels and so on. Okay, I will go next into the safety margin. Now in here, the safety margins looks like some kind of near to zero in here. Let's go to see. Oh, almost zero in here. So there will be a possible failure in here. Okay, and also above one in here. There is possible also a wrinkle in here. Okay, let's go continue into the thickness strain. Now, as you can see in here, when I click the maximum minimum, we found in here minimum is 27.5 and the maximum is 23. So it's above 10% and it also below minus 20%. The possible is in here we're gonna be experience a crack in here, and also in here we going to experience wrinkle. So I mean, this design for 3D addendum must be modified. So you can go back in here and you can modify all the curve that automatically created. Okay, but for this tutorial, I will not go into this one and to modify this. So I will just go straight to the costing, and then let's go to see the thickness also. You can see in here the thickness width is very low, minus 0.7. Meanwhile, our default thickness is 1 millimeter. And also in here, we have excessive thickening in here from 1 millimeters become 1.2. So yeah, it's clearly in here you're gonna get wrinkle and this is gonna be cracked. Okay, next we will calculate about the springback. Let's go calculate the springback. You can solve. Now this is the solve calculation for springback. You can see the report in here, magnitude. This is maximum 4 millimeters, minimum this one almost zero. No springback in here. What about the deflection? Deflection will be a plus minus. This is minus 1.5. This is maximum 3.6. Now, in order to get a good visualization, what is the minus and plus this one, you can use the comparison geometry using this shape. Okay. The first thing you do, you must define where is the location to start the calculation. I mean, this is the fixed point. Okay, this is the fixed point, the datum point for measuring springback. After this, you can click OK, and then you can show height to path. There is a comparison between the original and also the finished product. So you can see in here the reference is the gray one and the final product is the green one. So there's a big springback in here. You can click this for measurement. Okay, let's measure this. Looks big in here, right? So let's check. Yeah, it's about 9 millimeters, but is had a different element. So maybe we can clear selection, and yeah, this is the exact same element, about 8.9557 millimeters. So there's a big springback in here. So when you do the measurement, please make sure the element you select is the exactly same element, yeah, like this one. So you will get the correct result of the measurement. Okay. Yeah, I will close. Now, for the Springback calculation, there is also a Springback calculation after you trim the part. How to do that? We just copy in here, make the duplicate, and then rename it Springback after trimming. So click OK. Now you need to modify the input in here based on this trim to boundary. Click OK, and then calculate it. So this is the final result. You can see the Springback after trimming. Okay, this is the result. Okay, let's see the deflection, and let's do the comparison. Create 3 datum first for the measurement, and then click OK, and then compare between the finished product and the reference CAD geometry. So in here we have a Springback also. Okay, let's do the measurement. Okay, the same element, right? So this in the Springback is about 2.7. So it's gonna be like that. Springback. So we have Springback 1 and Springback after trimming. So this is the way to evaluate your design. Now, after finish evaluate the product, you can go into this one, into this flat blank in here. Okay, in order to create what it's called the nesting. Okay. Now, before I go to nesting, there's some information in here, what we call info. So the punch force, you see, after we create the addendum, okay, the punch force is increased 253 ton force. So this is the minimum required ton force to create the part like this. Okay, is compared with the example one, it just only need about 91 ton force. So this is more than twice. Okay, let's go into the flat blank. The next step is to create the blank definition. So this is the blank, the size of the blank. Okay, this is the length and this is the width. And then you can go into nesting. So in nesting, maybe I will create same gap. The gap on the A and the B is same like the example one. I use 5 millimeters. And then we're gonna calculate each of this. We're gonna calculate all. Okay, now we got this one. From the nesting optimization in here, we have layout 1, layout 2, layout 3, 4, 5, and so on. The number 1 is always the most efficient. We get the material utilization about 86%, the part utilization about 58%. Okay, and the cost per blank increase now is become 79 US dollar. Okay, and also you can see the gross weight, the net weight, and the part weight. Now please notice the part weight is exactly the same like the example one. Okay, so this is one up. Let me check the two up, a mirror, and cut off dice. So I think the one up is the most efficient. So in here, almost the same. You need about 1.8 meters in width if you have the coil, if you have the sheet metal. So it's gonna be as our guide to create the what is called the strip nesting. So in here I'm gonna put 2 meters and the length maybe about 4 meters, same like example one. Okay, I can click OK in here, and then The gap also the same, 5 millimeters. Click OK, and then for this layout we can solve all. Okay, now we got the one up layout. Layout number one, strip layout number one, efficiency 70.84, but utilization only 48%. In here we get number of parts, number of blanks, sorry. Only 7, 1, 2, 3, 4, 5, 6, 7. Okay. The cost per blank is 93 US dollar. Okay. So yeah, because we created addendum, it's more material we use. And that's why the cost per blank is higher compared to the example one. Okay, now we have two up, mirror, and also cut off dice. Okay, let's back on to one up. In here, we're gonna create line die plan, refer to the one up. So this is the blank. We're gonna select offline, same like example one. So it means that we cut our own blank inside our factory. Meanwhile, purchase, it means you buy from the vendor or supplier. Okay, click OK, this one. And then click the next step, generate blanking process. So this is the create the blank in OP10. Generate part features. So there is no other part features like flange something. So we just only create using the first form or draw. Create. Next we go same like example one, using as a type, only one blank to process. Click OK. And then in here you can choosing based on the window fit, based on the nesting layout, or you can choose the manual. I'm going to use based on window fit, same like example one. And then create die line up process. So in here, FormingSuite, create OP20 for drawing, OP30 trimming, 40 trimming, 50 trimming, and OP60 trimming. So in here, in OP60 just only one, OP50 just only two. Maybe I can combine this. Okay, maybe I can slightly change this one, become in here, so it will be part of OP40 now. In here, OP50, only one also. Okay, I will put this one into the OP40. Now OP50 has no process, the color become yellow. So I can delete the operation for the OP50. Now in here, the final is up in here. So maybe I will, yeah, put this one. And then I will delete the operation. Let's check, validate. So it's just a warning. This is the fields between part feature. Okay, no problem. But since we have a large Springback, maybe I will add at the end of the process is a restrike. So click in here, restrike. Okay, for restrike, I will not select all, maybe just only the flat surface in here. So I will edit restrike. I will click the control in here, the control button. So I will deselect all this one, or maybe I just deselect all. So I will click all the parts, the flat area, just the flat area. Okay. Okay. Okay, I will just select the flat area and then I click OK. So this is the strike. You can see the strike. So now it's getting simpler. Okay, 20, 30, 40, 50. Let's do the evaluation to validate the process. Okay, continue. And then I can save the process. Okay, now we continue to summary. OP10 create the blanking. So this is one station, just only to create blank. Meanwhile, OP20, OP30, 40, and 50. So this is OP20, OP30, OP40, and OP50. In OP20, this is the forming process. You can see all the color is red to the surface. Meanwhile, in OP30, okay, we gradually trim the surface, trim the surface, trim the surface. Now in OP40 also cut the remaining surface. Okay. Now this is what we call the interference cam. Okay, so maybe you can change the direction of the cam in here. I will explain how to change the direction of the cam in a progressive die tutorial using FTI FormingSuite. Maybe you can change something like this, okay? So the cam will not like this. Okay, the next is OP50 is the restrike. You see, just only these red surfaces. Now let's go into the detail in here. This is the summary. I mean the total for all OP20, 30, 40, and 50. Die load is 520. Is the total 283 plus 85 plus 85 plus 68. In here also you can get important information about the die build using the casting and using steel king dies, the die size, okay, the bed size, minimum stroke, shed height, stroke per minute, okay, press burden rate, and also the total die weight. Also in here you can see you must use 2 operators, and also in here the assumption the production volume is about 500,000. Parts per stroke is only 1. Okay. Now for the cost breakdown. Now this is the cost breakdown. Okay, the OP10, the cost for the design, machine, build, tryouts, material, and total. This is also the hours for each stage in here. And for the overall process, OP20, 30, 40, and 50, this is a summary, the accumulation. For design only, machine, build, tryout, material, total, and transfer and fingers also included in here, and the grand total, and the hours for each of it. So this is the report. It's similar like the example 1, but the only differences in here is the 3D addendum. Okay, so that's it, the tutorial for FTI FormingSuite. This is the example 2. You can compare with the example 1 to see the difference. Thank you for watching.